Here's an example label taken from a pretty common bottle of aspirin. Notice that the first warning is Reye syndrome, and it says that children or teenagers who are recovering from the chickenpox or flu-like symptoms should not use this product. Why is that? Well, Reye syndrome is characterized by encephalopathy, where encephalo refers to the brain, and pathy means that the tissue or organ isn't quite functioning properly. So there's some change in the way the brain's functioning. Reye syndrome is also characterized by liver damage and liver failure. This disease, though, is extremely rare, but when it does happen, it typically happens in children between the ages of 4 and 12, following an infection like the flu or chickenpox, and is highly associated with the use of aspirin during the infection. Since this association was found, the incidence of Reye syndrome has dropped significantly, and has led to the requirement of the warning seen on the label for aspirin. Why, though, does Reye syndrome seem to happen most often when aspirin is taken during an infection in children? Ultimately, the answer to this question is still unknown. What is known is that in patients with Reye syndrome, the mitochondria inside their liver cells, or hepatocytes, become damaged. Mitochondria do a few super important things for our cells, right? Including oxidative phosphorylation and fatty acid beta oxidation, both of which help provide energy as ATP to the cell. So mitochondria are the energy producers of the cell, right? And when the cells can't generate ATP, they can eventually die because they've lost their main source of energy. Since the liver cells seem to be the main cells targeted in Reye syndrome, the liver becomes one of the main organs affected. Still, the question of how mitochondria, specifically in hepatocytes, become damaged remains mostly a mystery. It's known that salicylates like aspirin are able to uncouple oxidative phosphorylation, essentially meaning it makes it not work anymore, which might help to explain their involvement in mitochondrial destruction. But it's still unclear what relationship exists with viral infection, though there certainly seems to be one. Whatever the case, as the hepatocytes die and the liver becomes dysfunctional, blood doesn't get filtered, and so it doesn't get the nitrogen-containing toxins filtered by the liver like it normally would. This leads to an increased amount of ammonia in the blood. Since ammonia can diffuse across the blood-brain barrier, it starts to interfere with brain function, causing the characteristic encephalopathy seen as Reye syndrome progresses. Ammonia appears to mainly target astrocytes, a type of glial cell in the brain, and although the mechanisms aren't fully understood, ammonia seems to cause astrocyte swelling and oxidative damage. As ammonia damages brain cells, the brain becomes more inflamed, leading to swelling and edema characteristic of encephalopathy. These patients then progress through a series of general encephalopathy signs and symptoms related to declining brain function, increasing cerebral edema, and increasing intracranial pressures. First, the patient might be quiet, lethargic or sleepy, and they might also vomit. Next, they enter into a state of stupor, with the potential for seizures, decorticate responses to stimuli, along with an intact pupillary reflex. At stage 3, patients might enter into a coma, and now might present with a decerebrate response, and no longer have a pupillary reflex. In stage 4, the patient moves into a coma and they lose their deep tendon reflexes, and they rapidly decline to stage 5, which is death. Blood tests for Reye syndrome will be reflective of liver damage and mitochondrial damage. For example, you'd expect to see an increase in transaminases, which are liver enzymes used for amino acid metabolism, that get into the blood as liver cells die. Again, serum ammonia will be up since the liver is not removing it from the bloodstream, and higher levels usually indicate more severity. Prothrombin time, which is the time it takes blood to clot, is usually also elevated, and this is because the liver plays an important role in the production of coagulation factors, which help coagulate blood, or clot. So when the liver is dysfunctional, coagulation factor production is decreased, and so it takes longer for blood to clot. The liver also plays a huge role in regulating the storage of glycogen. When food is ingested, the liver helps convert glucose to glycogen. When food is restricted, the liver helps convert glycogen to glucose for energy. Therefore, when the liver is dysfunctional, it's not able to convert glycogen to glucose when food is restricted, leading to low blood sugar or hypoglycemia. Likewise, with food ingestion, it can't convert glucose to glycogen, and patients get high blood sugar, or hyperglycemia. Treatment of Reye syndrome usually involves careful monitoring and supportive measures in intravenous fluids. The damage to brain cells induced by ammonia tends to lead to cerebral swelling, inflammation, and edema, which lead to the worsening symptoms associated with encephalopathy. So a major goal is to reduce the swelling and edema. Mannitol or glycerol might be given as a way to try to reverse the osmotic gradient with cerebral edema and essentially pull some of this fluid from the brain back into circulation. Also, induced hyperventilation might be used to help reduce fluid buildup in the brain as well. Thanks for watching. You can help support us by donating on Patreon or subscribing to our channel or telling your friends about us on social media.